Hello everyone, I am K. Rashmi Raj from Tribly. Today I am discussing about my AAT presentation topic, that is quantum switching and quantum merge sorting. First, quantum computing and quantum information science QIS. That study the exploration of quantum mechanics provides us advanced tool to solve difficult problems in traditional Turing machines. The fundamental element in the quantum field can be any particle with two states that coexist together, such as photon, atom, electron, or subatomic particles. All of them are under the nanoscale. This QIS, namely quantum computing and quantum information QIS, is often considered to be a basic for future research and innovations in the further development of nanotechnology. In literary, many outstanding algorithms have been developed to illustrate that quantum based computers are more powerful than traditional computers. For example, SHOR 4 represents a quantum algorithm that factors a composite integer exponentially faster than the best classical algorithms do. And Grover presents a quantum algorithm that searches an item from an under structure like polynomial speedup over classical algorithms. Due to its potential impact and significance, QIS has drawn more and more attention in the recent decade. One of the most important applications in QIS is the quantum computing, that is a mechanisms for transferring quantum data from one location to another. Among them, quantum wire is one of the such medium for transporting quantum information. At present, many remarkable research issues based upon the quantum wire configuration, such as quantum teleportation, quantum cryptography, quantum repeater, and quantum networks, have been raised. These results have driven the QIS field further into real world applications. And many views of the future of QoS indicate that the need for basic quantum wire components would become more essential due to explosion growth of quantum devices. As shown in the figure 1, as shown in this figure 1, in order to ensure that any two quantum devices can communicate quantum data with each other, it is necessary to employ a quantum wire between them. However, this results in a fully connected quantum network that would require quantum wires to construct. Where is the total number of quantum nodes in this paper? In this paper, a novel quantum switching architecture is proposed to avoid the fully connected quantum networks. As shown in the figure B, with the aid of quantum switching, quantum nodes only need to deliver their quantum data to quantum switching, and the quantum switching would switch to. Many views of the further of QIS indicate that the need for the basic quantum wire components would become more essential due to the explosion growth of quantum devices. And I have discussed this. So each quantum node only requires one quantum wire to connect with quantum switching, so the number of quantum wires can be reduced too. And the Purposed quantum switching allows each input quantum data to be permuted to its corresponding destination port in parallel dimen- dimensionally dynamically. Moreover, to minimize the time delay in executing the quantum switching, an effective quantum match sorting QMS algorithm is developed in this paper. Although it has been shown that quantum computers in general cannot greatly outperform classical computers for the task of sorting. This paper makes use of the parallel computing techniques to reduce the running time of the QMS algorithm so that it only takes time complexity to sort quantum elements. Next, because the purposed quantum switching utilizes the effective QMS algorithm, the total execution time can be reduced to algorithm time. In addition, in order to assess the facility of the quantum switching, we also define three different performance indexes to evaluate the effectiveness of quantum instruments. According to the result, it can be seen that the purposed quantum switching is feasible to put into practice. This paper represents one of the few attempts to solve the dynamic quantum switching in the literature. The remainder of this paper is organized as follows. In session 2, the general concepts about quantum computing are introducing related research in surveyed as well. In session 3, the QMS algorithm that provides a parallel quantum computing is presented. In session 4, the quantum switching architecture is proposed to switch quantum data to its corresponding port. Backgrounds and related work. In this section, we introduce definitions and terminologies used in describing the pro- proposed mechanics throughout this paper. In-depth treatment of the notations can be found in the literature. And here is the picture which I have explained in that theory. A is that a parallel communication of quantum, and B also, and C is the quantums is to the layers number of layers opened and the quantum computing. These all matters about the quantum computing. Next, first start. Read n positive numbers and then convert all numbers to binary. Next, start. Because many breakthroughs in quantum computing communication have been discovered. This results in the fact that the demand for establishing the communication networks become more and more urgent. To save the cost in building the quantum backbone network, this paper proposes a quantum switching architecture that can be applied to switch each input quantum data to its corresponding destination port correctly. The proposed quantum switching employs an effective QMS algorithm as a subroute, so the total execution time can be reduced in polymeric algorithm time. More precisely, the quantum switching only requires space communication and can be implemented with quantum gates. Furthermore, The quantum switching achieves a better performance in a time complexity of based on these advantages. It can be seen that the proposed quantum switching is feasible to applied when constructing high performance quantum networks. And thanking you, signing off, Rashmi Raj.